Alright folks, welcome to naming ionic compounds with polyatomic ions. A couple of things here. I will assume that you have your ion chart in front of you. So you need to have your ion chart. If you do not have your ion chart, find it, because you're going to need it, because you can't do this without it. Right? And there are also at least 6 polyatomic ions that you were supposed to memorize. Those were ammonium. I'm just going to write them this way. Ammonium, which is with a 1+ charge, hydroxide with a 1- charge. Let's see, what were the other ones you had to memorize? Nitrate. Nitrate is NO3, and it has a 1- charge. And you had to memorize carbonate, which is CO3 with a 2- charge, and sulfate, which is SO4 with a 2- charge, and phosphate, which is PO4 with a 3- charge. Now, those are ones that you absolutely must know for the SOLs. Right? So there may be more that you should memorize, but those are definite requirements for the SOLs. Right? So anyway, that's what we're going to go and name these, and we're going to name them pretty quickly. Right? Now remember, when you are naming, so far, all you're doing is looking at the first thing, which is going to be a metal. The metal is going to retain its name, so that's going to be sodium. And when you're looking at polyatomic ions, you're going to look on your ion chart for these things over here. Now again, this is one of those that you should have memorized, and so this is nitrate. Remember, when it's on your ion chart, it's probably going to end in ate or ite. It might end in ide, that's possible. Like the next one's going to end in ide, but when typically the things that are on the periodic table end in ide. Alright, so let's look at the next one. The next one is going to be barium and cyanide. B-A-R-I-U-M and cyanide. Right. So now I'm not going to write all these out because, again, that'll take forever. But what we're doing is we're looking for a metal on the periodic table. And then we're looking, at least for right now, we're looking for whatever the anion is that's on the right. We're looking for that on your ion chart. So you'll see that this is lithium and sulfate. And then this is potassium and phosphate. So it's just called potassium phosphate. Right. This one looks a little strange. This is cesium, and this big long thing here, which frankly does not need the parentheses around it, is cesium acetate. How about this one? This one you have to be very careful. Right? You might be tempted to say magnesium nitrate. It's not. You'll notice that it's NO2 instead of NO3. And because it's NO2, this is nitrite. So be very careful, because magnesium nitrate is with an NO3, magnesium nitrite is with an NO2. So the endings are extremely important. This one is calcium carbonate. This is strontium phosphate. This is sodium, and this big thing here, you have to look for that, HCO3. HCO3 is bicarbonate. So this is sodium bicarbonate. And then this one is potassium. The thing on the left is potassium. And the thing on the right is hydroxide. All right. Number 11 is going to be barium with hydroxide on the right. So it's barium hydroxide. And then aluminum acetate. And then aluminum, be careful with this one. Typically SO4 is what you're looking for. That's sulfate. But this is sulfite. So this is aluminum sulfite, and right below it is potassium sulfite. And then calcium, be careful, you have to look for these things. They're typically 2 words. Calcium, and then look for SCN on your ion chart. Now, SCN is thiocyanate. Thiocyanate. So this is calcium thiocyanate. Now those are pretty easy. It's when you're going from the names to the compounds that it gets a little bit more difficult. So the way I do these, I do 2 things. I look up what the items are. For example, the first one here is going to be barium, and then chlorate. So I look up chlorate on the periodic table, and chlorate is ClO3. Then I look up charges, and I notice that barium is a 2+ charge, and chlorate is a 1- charge. Right? So that means when I do my crisscross, I have to have 2 chlorates. I want to have 2 chlorates. So how do I have 2 chlorates? I put the entire chlorate thing inside parentheses and I put a 2 out there. Because I want to have 2 of the whole things. Right, so you have to be very careful when you're doing this. Alright, let's try the next one. Magnesium acetate. Acetate is C2H3O2. And now I look at my charges, and magnesium is a 2 plus charge again, and acetate is a 1 minus charge. So again, I need 2 acetates. I have to have 2 of these whole things, so I have to put the whole thing inside parentheses. How about barium sulfate? Well, barium is Ba, and sulfate you should memorize. That's SO4. And barium has a 2 plus charge. And again, as part of what you're memorizing with sulfate, it has a 2 minus charge. The 2 and the 2 cancel, so I'm done. How about potassium chlorite? Well, potassium is K, and chlorite, well, that's real close to chlorate. Chlorate is ClO3. And remember that if you have an ite, it has 1 less oxygen. So it would be ClO2. So even without looking that up, if you knew what chlorate was, you could figure out what chlorite was. Potassium has a 1 plus charge, and chlorite has a 1 minus charge. So your final answer is KClO2. How about sodium hydroxide? Well, sodium is Na, and hydroxide is OH. So that's a 1-to-1 relationship because sodium has a 1 plus charge, and hydroxide has a 1 minus charge. This one, I guarantee you'll see it on a test because students always miss it. Okay, and it's very, very important that you get this right. This is one of those that is always on the SOL because they like to trick you. Okay, so let's look at what this is. This is magnesium, this is Mg, and hydroxide is OH. So if I look at magnesium, it has a 2 plus charge, and hydroxide has a 1 minus charge, and what you're going to do is say, oh, so I need 2 hydroxides. Let's just put a 2 there. That answer is incorrect. Right? And the reason that answer is incorrect is you do not, what you just did was you now have 2 hydrogens, but you don't have 2 oxygens. You absolutely must put the OH in parentheses. Right? So your final answer is going to be MgOH inside parentheses 2. Alright, let's look at beryllium cyanide. Beryllium is an alkaline earth metal, so it's a 2 plus charge, and cyanide is a 1 minus charge. So beryllium is Be, and cyanide is Cn. So we have exactly the same problem with beryllium cyanide that we had with magnesium hydroxide above. I need to have 2 cyanides, so I need to put it inside parentheses. How about calcium phosphate? Right, well, calcium is a 2 plus charge, and phosphate's a 3 minus charge. Calcium is Ca, phosphate is PO4. Remember, you have to memorize that one. That's one of those you have to memorize. And I need 3 calciums when I do my crisscross method. I need 3 calciums, and I need to have 2 phosphates. So I need parentheses around the phosphates. Right? How about aluminum hydroxide? Well, aluminum is Al. Hydroxide is OH. Aluminum has a 3 plus charge. Hydroxide has a 1 minus charge. When I crisscross them, I need 3 hydroxides. You must remember those parentheses, folks. It's AlOH, 3 with 3 outside the parentheses. How about aluminum phosphate? Aluminum is a 3 plus charge. Phosphate's a 3 minus charge. Aluminum is Al. Phosphate is PO4. PO4 is something you have to memorize for phosphate. And the plus 3 and the minus 3 cancel. So we're good on that one. It is AlPO4. All right, now these get a little bit trickier. We have strontium. If you look up strontium on the periodic table, strontium is in column 2. It is a, you guys can see my cursor, but I can't. Strontium is Sr, and per sulfate, well, sulfate is, let me just write it here, sulfate is SO4, but per sulfate tells you it has an extra oxygen. So this is SO5. It still has a 2 minus charge. The sulfate has a 2 minus charge. So this is SO5, and it has a 2 minus charge. And strontium is an alkaline earth metal, so it has a 2 plus charge. So I'm done. It's Sr, SO5. I don't need to add any more subscripts. How about strontium hypophosphite. Oh gosh. Well, phosphate is PO4. Phosphite would be PO3, because you lose an oxygen. And the hypophosphite would be PO2. And they all have a 3- charge, because your charges don't change. Right? So if I have a PO2 for hypophosphite and strontium, which is SR, now strontium we already know has a 2+ charge. Hypophosphite has a 3-. When I cross them, I need to have 3 strontiums, and I need to have 2 hypophosphites. So again, I need parentheses when I do that. Right. Radium peroxide. This is one that's going to look a little strange. Radium is Ra. Peroxide is O2. Again, look on your ion chart and you'll find peroxide, and it is O2. Radium has a 2+ charge. And peroxide has a 2- charge. So I am done. This is RaO2. And yes, that looks a little bit strange, but that's the way it is. Alright, radium is Ra, and perchlorate. Well, chlorate is ClO3. And perchlorate means you have an extra oxygen, so it's ClO4. So this is RaClO4. Now, chlorate, if you look on your ion chart, is a 1- charge. And radium is in group 2. It's an alkaline earth metal, so it has a 2+ charge. So that means I need to have 2 perchlorates. So I'm going to have 2 perchlorates down there. How about francium hyposulfite? Well, francium has a 1+ charge, and I'll get back to hyposulfite in a minute. Francium is Fr. And hyposulfite, well, let's see, sulfate is SO4, sulfite is SO3, hyposulfite is SO2, and they all have a 2- charge. So this is SO2, and I have a 2- charge, so that means I need 2 franciums when I cross. So that's Fr2, SO2. All right, folks, that's what you got to do. Need more help? See me in class. Got to practice. Need rote. Do it over and over. I'll see you in class. Let me know if you need help. See ya. Bye.